Okay, excuse me. So A equals V over T. It's already solved for A. We could solve for V, or we could solve for T. And you asked, how do you know if it's a fraction or not? Well, you don't have to know. If you just follow the standard rules for how do you get a letter alone, then it will become what you need it to become. Just the same rules as if you were solving for X in a problem like this. You don't know if your answer is going to be a fraction or not. You just know that you have to, work towards getting X alone. And so you have to get rid of both the 2 and the 5, and always get rid of what's not attached to the letter first. So we'll get rid of the 5. So we subtract 5 from both sides because it was being added, so we subtract it. Always doing the opposite operation. So then we get this, and then X now has a 2 with it, and it's being multiplied by 2. So to get rid of the 2, we have to do the opposite operation, which is division. So we'll divide by 2. So I think these you do pretty well with. And there we say X is this. It turned out to be a fraction for the answer. So up here, we don't know whether our answer is going to be a fraction or not. We just need to follow those same steps of getting whichever letter alone that it tells us to. So we're going to solve for V this time. So if I'm going to solve for V, that means I want V by itself. And so then I have to just get rid of the T. Well, what's happening here is V is being multiplied by T when they're sitting next to each other. So to break that bond, I have to do the opposite of multiplication, which is division. So I'm going to divide by T to get that out of there, and I have to do it to both sides. So now I have A divided by T equals V. So there we have V alone. If I needed to get, if I had started with the same problem, and we have A equals VT, and this time they said solve for T, then we're going to get rid of the V. And again, that bond of V times T is what's happening. So in order to get rid of the V, it's being multiplied, so I have to divide on both sides. And that cancels this one out. This one doesn't cancel out, so it's A divided by V equals T. So the result comes out because we followed our general rules of if you want to get rid of something, you have to do the opposite of what it's currently doing. So if we had had a problem that said A equals V over T instead, and it said solve for V, that means get V alone. So we have to say, well, what's happening to V? It's being divided by T because fractions are division. So if T is being used to divide it, if you want to get rid of T, you have to do the opposite of division, which is multiplication. And so if I multiply both sides by T, then I get A equals, AT or TA, either one, equals V. If I had started off with A equals V over T, and they said solve for T. Well, the T isn't being divided. It's the V that's being divided. T is being used to divide. So what we're going to do is we're going to move the T over. We couldn't divide by V because V isn't on the bottom. So or even if we multiplied by V, since V is not on the bottom, we can't. V isn't the thing being used to divide with. T is. So we're going to multiply by T on both sides and get that TA equals V. And then, working towards getting that T alone, now we can see that T and A are being multiplied. So I have to divide by A. And now we have our answer. So it's not about how do you know if it's got a fraction or not. It's about taking the steps to get the letter alone that they've told you to get alone, and you look at what is currently happening to it, and you do the opposite. If it had said A minus T equals V, and they said get A alone. Well, T is bothering it, and what it's doing is subtraction, so we'll do the opposite of subtraction to get rid of that t. And so then we would have A is equal to V plus T. Hopefully that clears that up a little bit for you.